All right, so this is part 2 of lesson 3.7. We are going to start out by defining what is the elasticity of demand in terms of a formula in the math class that we're using. And then we're going to go to example how to explain certain product is. What kind of elasticity is that product? Is it worth it to increase the price? Is it not worth it? So the first thing we have here is the definition, how we define elasticity of demand in this class. So given a price and demand of a product related by this equation, and we define that as x equal to f of p. So this is the demand equation. X is demand and p is price. So this is saying that x is in term of p, or f of p itself is the demand equation, meaning demand is depending on price, okay. So if that's what we're given, we're gonna define E of P. Let's define E of P. So we're gonna say let's define E of P itself, and we're gonna define that as the elasticity of demand of that product at the current price P. Okay, and the formula is the following. So we said E of P itself is defined as the negative of these two ratio. Okay, so we're going to have the ratio of the relative rate of change of demand over the relative rate of change of price. Okay, so we are comparing two relative rate of change. We're going to take the ratio of those two things. So in order for us to figure out, what is the sensitivity or the elasticity of demand of that product at the current price P, we're going to look at the two ratio. We look at the ratio of the two derivatives in this case here. We look at the relative rate of change of demand and the relative rate of change of the price. We're going to compare those two things. And I'll explain why we need that negative in a second. But recall from the last video, we defined the relative rate of change of demand as the f prime of p over f of p. How did I get that? Well, we know that by definition, f prime of x over f of x is the general formula for relative rate of change of any function. So if we want to look at the relative rate of change of demand, we take f prime of the demand functions, right? And then divide that by the function value itself. So that's just the numerator. Now in the denominator, we have the relative rate of change of the price. So what is the price function in this case? So price is just p. So the derivative of p on the top is just going to be 1, and then over the function value which is f of x in the bottom. In this case, the function for the price is going to be p, so it's going to be 1 over p. Using algebra, we can simplify this fraction to the negative of p times f prime of p over f of p itself. So that is the math formula for calculating the elasticity of demand of any product at a current price. Now, why do we need the negative? So it turns out that P is always positive. The demand of any product is always positive. Oh, let me go ahead and erase that. Oh, let me go back to that. Let's erase this. All right, change to red. So this is positive, and this is always positive. The change of demand is going to be negative. The rate of demand is going to be negative the moment we increase the price. So this is going to be negative, and we want to define a value that is consistent. So we want this EP to be a positive value. So this negative and that negative will keep the EOP value be positive. And this value is going to come out to be usually greater than 0 and sometimes greater than 1, but it's going to be mainly between 0 and 1. And we're going to break that down further as the following here. So we have E of P, we have the demand, and then we have the revenue. So if we calculate the EOP or the elasticity of demand at a certain price for a product, and that elasticity of demand is between 0 to 1, then we call this type of demand is inelastic. Okay, and this means that this means that this means inelastic, that means demand is not sensitive to price change. So increase in price will result in an increase in revenue. Okay. All right. So an example of this would be like, something that like water, right? Or SMUD, right? Something that deal with necessity that we need. And we can have an example where we calculate the EOP and then the EOP value is greater than 1. Okay. So that means the demand is elastic. Okay. And if demand is elastic, the demand itself is very sensitive to price change. So any increase in price will result a decrease in revenue. Okay. All right. So an example of elastic demand would be something that we don't really need to survive. I would say clothing brand will be an example of that, right? So if one brand of clothes is more expensive than the other one, we have alternative option to buy at a lower price. So that would be an example of elastic demand. And the third scenario is when we have the EOP is equal to 1. So this is called the unit demand. So this means any increase in price, the demand will change the same ratio, same percentage of increase in price. So revenue will stay the same. So there's not much going on there. So these are 3 type of demands we can have for any product. We can have inelastic demand, and then we can have elastic demand or unit. Okay, the 2 that we focus the most is either inelastic or elastic. Now, if you guys want, I can do another video to explain where we get these numbers from as well. So there is a math word to explain where we get these numbers. Not taking another 10 minutes or so. So I'm gonna go ahead and end here, and the next video I'll show you guys how to solve problems or example in this lesson.